Now, Learning Target 1.2 and Learning Target 1.3 on the Unit 1 test are closely related. 1.2 is the actual work to solve the equation, but 1.3 is the writing that you do on the side to justify each of your steps. Remember that justification means what did you do? Why did you do it? And then what property of algebra said that you could do that? You need all three of those parts on each of your justification steps. So when I look at this problem, the very first thing that I would do, if it's 2x minus 12 equals 10, is to say I don't want this variable term and constant on the same side. Since there's a constant on the other side, I want to eliminate this constant on the left. To eliminate a minus 12, I would add 12 to both sides of the equation. And when I do that, I end up with 2x equals positive 22. Now, I'm going to show you the justification of that step now at the same time. Because it's very difficult to write with this on the slides and write neatly, especially in such a small space, I went ahead and typed up the justification for each step in advance so that I could just show it to you. So what I did, I added 12 to both sides of the equation. Why? To eliminate the constant on the left. And what property allowed me to do that? The addition property of equality. Now I have 2x equals 22, so I have a variable term on the left and a constant term on the right. I want to undo this multiplication, this 2 times x, because I want to know what 1x equals. Well, the way I undo multiplying by 2 is to divide both sides by 2. So I end up with x equals 11 for my answer. And again, the justification for why I did that, what I did, I divided both sides by 2. Why? To isolate the variable. What allowed me to do that? The division property of equality. When I look at this equation, it's very similar. I have a variable term and a constant on the left and a constant on the right. But in this case, when I want to eliminate the constant on the left, it's a plus 3. So the way I eliminate that is to subtract 3 from both sides of the equation. And I end up with negative 5x equals negative 30. Now, the justification, what I did, I subtracted 3 from both sides of the equation. Why? To eliminate the constant on the left. And the property that allowed me to do that was the subtraction property of equality. Now, the thing that's being multiplied by the x is negative 5, so I'm going to divide both sides of the equation by negative 5. Because I have a single variable term on the left and a single constant term on the right, I don't have any more addition or subtraction to undo. When I do this, I end up with x equals positive 6. And once again, the reason I did that, what I did, I divided both sides by negative 5. Why? To isolate the variable. What property allowed me to do that? The division property of equality. The last one people think is a little bit scary, but it's actually very similar. I still have a variable term and a constant on the left and a constant on the right. I want to move this constant to the other side. To eliminate a plus 8, I would have to subtract 8 from both sides. And I would end up with x over 4 equals positive 22. So my reasoning for this, my justification, is very similar. What I did, I subtracted 8 from both sides of the equation. Why? To eliminate the constant on the left. What property allowed me to do that? The subtraction property of equality. At this point, the thing that's connecting my number to my variable is division, because a fraction bar is division. So to undo dividing by 4, I need to multiply both sides. So 4 times x over 4 is equal to 22 times 4. So all I did was I multiplied both sides of the equation by 4. Otherwise, the equation here in the middle looks the same. Well, if multiplying by 4 undoes dividing by 4, then this side is just x, and then 22 times 4 is 88. So, my justification, I multiplied both sides by 4. Why? To isolate the variable. What allowed me to do that? The multiplication property of equality. So that's Learning Targets 1.2 and 1.3 on the Unit 1 test.